the exercise 5.1. Find the discontinuity of f where f is defined by section 1. F of x is equals to the value of the function is 2x plus 3. F of x is equals to 2x plus 3 if x is less than or equals to 2, and the function is 2x minus 3 if x is greater than 2. So here the function is in pieces, means here the function are more than 1. Hence we use the identity limit as x tends to c minus f of x is equals to limit as x tends to c plus f of x is equals to f of c. So solution, let us consider a function. Let us consider the function f of x is equals to 2x plus 3 if x is less than or equals to 2. 2x minus 3 if x is greater than 2. Now we know that the identity limit as x tends to c minus limit as x tends to c plus equals to f of c. We use this formula to check the point of discontinuity. Means here they ask find the point of discontinuity if exists only, otherwise the function is continuous. See here, now when x is less than 2, we take as a LHM for any value of x which is less than given limit, we consider that is a left hand limit. For any value of x is greater than limit, that considered as a right hand limit. Here the function for the left hand limit is 2x plus 3 and the function for the right hand limit is 2x minus 3. X is greater than limit, it is a RHM. X is less than or equals to limit, then that is a LHM. Here LHM is equals to when we say that function is continuous, if the function obeys this condition, so that is function is a continuous function, otherwise it is a discontinuous, and that limit is the point of a discontinuity. Here we have to check here LHM is equals to limit as x tends to c minus f of x. This is limit as x tends to 2 minus, because limit is 2 here, 2 minus the function when x is less than 2, the function is 2x plus 3. It is a 2x plus 3. So taking limit means put the 2 here in place of x, because there 2. So this minus sign indicates only the limit moving from left hand to the limit. If it is plus, it is moving from the right. That is but not put here minus 2, because the minus sign indicates the value of the domain moving from left to the limit. That is the reason why they are written a negative sign. So put the value of x here 2, that is 2 into 2 plus 3. This is 4 plus 3. This is 7. This is LHM is equals to 7. Similarly find RHL. RHL is equals to, that is limit as x tends to 2 plus, that is function is when the function x greater than 2 limit, that is a 2x minus 3 c plus f of x, that is a limit as x tends to 2 plus, that is 2x minus 3, taking limit that is 2 into 2 minus 3, 4 minus 3, that is 1. So that this is a RHL. Here the LHL is 7 and RHL is 1, hence the limit does not exist. LHL is not equals to RHL, therefore point of discontinuity. What they asked? Find the discontinuity of f, where f is defined by. So they asked the point of discontinuity if it exists. Yes, here 2 is the point of discontinuity. It means that at 2 the function is discontinuous, because here left hand limit and a right hand limit so does not coincide. Only when we say that a function is continuous if LHL is equal to RHL. It means if the limits are exist, then we move forward to find f of c. It means if LHL is equal to RHL, then we have to find f of c. If LHL is not equal to RHL, it is not necessary to find f of c. Only after checking the LHL and RHL, if the limit does not exist, then we can easily say that the function is discontinuous. Hence, the point of discontinuity of this function is 2. So, yes, dear students, next question is, that is the seventh one. Find the discontinuity of the f, where f is defined by f of x is equals to modulus of x plus 3 if x is less than minus 3, less than or equals to minus 3, and minus 2x if x is greater than minus 3 and less than 3, and the function is 6x plus 2 if x is greater than or equals to 3. Here the function are in pieces. There are more than one functions. There are 3 functions. The function in pieces, 3 pieces. So we have to first relate between this and this, LHL and RHL. Again between this and this. For these two, this is LHL and this is RHL. For these two, this is LHL and this is RHL. Like this. So now I can write this function as f of x. Now f of x is equals to, I rewrite this function as, because here modulus of x is nothing but this is equals to plus or minus x. Here plus x and minus x. It has 2 values. But here, since x is less than minus 3, means the x is less than minus 3, and only we take as a minus x, because it is in the, since this is the modulus function, and we have to convert into algebraic form. Hence it is minus x plus 3. Why we taken here minus x? Because x is less than minus 3, hence we have taken here minus x instead of a plus x. Okay, so I convert this function into like this. Now if x is less than minus 3, now this is minus 2x. If x is greater than minus 3, less than 3, 6x plus 2. If x is greater than or equals to 3. So now check the continuity of the function. Check the continuity of the function at x equals to minus 3. See here there are 2 limits exist. One is minus 3 and another one is 3. First, we have to check the continuity of the function at x equals to minus 3. So here also the function is in pieces, hence we use the LHL. So LHL is nothing but this is LHL equals to limit as x tends to. So because already we know the identity, that is limit as x tends to c minus equals to limit as x tends to c plus equals to f of c. If the function obeys that satisfies the condition, then the function is continuous. Otherwise, it is a discontinuous. See here, limit as x tends to c minus f of x. See here, limit as x tends to, that is the function is left hand limit is minus 3 minus. On that occasion, the function is minus x plus 3. Okay, minus x plus 3. So taking limit taking limit, what happens when you put the value of x is minus 3, that is minus of minus 3 plus 3. This is minus into minus plus 3 plus 3. This is equals to 6. What is our LHR? That is a 6. Similarly RHR is equals to, RHR is nothing but this is the limit as x tends to c plus f of x. Same. X is greater than minus 3. When x is less than minus 3, the function is here. This function is here. This function minus x plus 3. When x is greater than minus 3, see here. When x is greater than minus 3, so the function is minus 2x. That is the RHR. For these two functions, this is LHR and this is RHR. Okay. So this is limit as x tends to minus 3 plus, because here this is left hand limit, hence we taken minus. This is right hand limit. The limit is nothing but minus 3. Here also minus 3. But signs are changed here. Okay. This is the RHR. So when RHR, the function is minus 2x. Minus 2x. Taking limit. What happens when you put x equals to minus 3 here? Minus 2 into minus 3. Okay. That is minus into minus plus 2 into 3, 6. This is RHR. And now find f of x is equals to here is equal to symbol exists here. On that occasion the function is here exists here. On that occasion the function is minus x plus 3. Minus x plus 3. Okay, by putting the values minus 3, because this is the f of c. We are going to find f of c. That is minus 3. That is minus of minus 3 plus 3. This is nothing but 3 plus 3. This is a 6. Therefore, by observing all the three terms here, 6, 6, 6. Hence, therefore, limit as x tends to minus 3 minus 3 equals to limit as x tends to minus 3 plus is equals to f of minus 3 is equals to 6. Therefore, the function is continuous. Function is continuous at x equals to minus 3. Okay, this is the continuity of the function at x equals to minus 3. Now the function, the example is still there. So now we are going to find the continuity of, to check the continuity of a function at x equals to 3. Okay, we find the continuity of a function at x equals to minus 3. So now we are going to find the continuity of a function at x equals to 3. At x equals to 3. Here also, for at x equals to 3, we consider these two functions. For at x equals to minus 3, we consider these two functions. Now we are using these two functions for at x equals to 3, because this starts here from here. When x is less than 3, we consider this is the LHR. So that this is at x equals to 3. The limit is 3. Therefore, limit as x tends to 3 minus, on that occasion the function is minus 2x. Minus 2x. Taking limit means put 3 in x, that is minus 2, 3, that is minus 6. This is LHR. Similarly, RHR, that is limit as x tends to 3 plus f of c plus f of x. Limit as x tends to 3 plus, on that occasion the function is 6x plus 2. 6x plus 2. Taking limit, we get, put x equals to 3 here. X equals to 3. It is 6 3s are 18 plus 2. This is equals to 20. This is RHL. So observe and LHL and RHL. Therefore, LHL is not equals to RHL. LHL is not equals to RHL. Hence, it is not necessary to find f of c. Therefore, limit does not exist. Limit does not exist. Therefore, the function is discontinuous at x equals to 3. So this is the continuity of the function at x equals to 3. Means at x equals to minus 3 the function is continuous, but the same function at x equals to 3 the function is discontinuous. Okay, thank you.